So the first thing I want to draw your attention to when we're talking about standard form and vertex form is this is your formula chart. So both of these are in fact on your formula chart. You don't have to memorize them, okay? So I just want you to be aware. Remember, that is always implanted. It'll be on star. It's going to be in anything we do in Eduphoria. Some things that we've talked about. Actually, let's do vertex form first because it's the one we're most familiar with. Different things that we've talked about. The A, right? If it's a negative, it's going to open down, which will cause us to have a maximum, okay? You might also see this as reflect over the x-axis. We also talked about if A is bigger than 1, this is a vertical stretch, which means that it's going to get narrow, right? And that's our bench press, right? Versus when A is between 0 and 1, this is that vertical compression, which means it's going to get wider. We talked about the H. H is inside. What do we remember about inside? Insiders what? They lie. All right, so when we look at this, for H, if it's a negative H, it's actually going right. And if it's a positive H, it's actually going left. So remember that these were going to be our left, right. And inside the parentheses, this is a horizontal, right? Because the parentheses is like the fly machine, right? It's a left-right movement. We talked about K. This is a vertical movement, right? And it does exactly what it says. Positive is up, negative is down. So when we talk about the standard form, some of these letters do some other things for us. Okay, it's got the A, so the A is going to be the same as the A in vertex form, right? Negative is going to open down. We can just essentially write what we did a minute ago. This is going to, or we can also write reflect over the x-axis. We said this was a vertical stretch. You can abbreviate if you don't want to write it all out again, or you can just say draw, and you could even draw an arrow to the other side versus a vertical compression. Now, the new one that we haven't really talked about, B is a special thing. It kind of does its own thing. We're not going to worry about that part, is the C. I want you to realize that the C, the constant, the one that doesn't have a letter in standard form, that is always going to be your y-intercept, okay? So that actually is going to give you a clue to some of the pieces if we're graphing. So we have some steps here on how we're going to convert. And we did a little bit of this yesterday. Okay, we need to expand our parentheses and simplify. We're going to leave our new polynomial in the parentheses. So what that's talking about is that's talking about this little 2. We talked about that yesterday. When you square something, you're timesing it by itself. So if we're going to expand this, I'm just going to draw an arrow so you can see what that looks like. We're not doing anything with that 3. We're just going to go ahead and write it. And if we're going to expand this, we're going to write x minus 2 times x minus 2. That way we have expanded it. We can see what's happening. And we're going to simplify that. That means we're going to do box or we're going to do multiplying. It's up to you. I believe most of you preferred the box. Okay. I don't really have a lot of space, but you guys are really good at the box. I'm going to tell you that this is going to be x squared minus 4x plus 4. And then we're going to bring down that 7 just like we brought down this 3, okay? You guys can do the box. I know you know what that looks like. Distribute our A, okay? It only goes to what is in the parentheses, guys. Only here, here, and here. It is not going to go to that negative 7. It is not in the parentheses. So let's look at that. So we get 3x squared minus 12x plus 12, and we're just bringing this minus 7 down, just like we did yesterday. And the last thing is collect like terms. So that's going to be our final answer, 3x squared minus 12x. What's 12 minus 7? 5. Now, you can, of course, double check this. We talked about that yesterday as well. If we graphed this and we graphed this, they should overlap just like we did in the last unit. So on this example, we're going to expand. We're going to rewrite it to standard form. We're going to pull out the vertex from the vertex form. Remember the y-intercept, that is going to be our C, right? So let's make a couple of notes here. This is our HK. This is going to be our C in standard form. We can find our buddy points and so on. Desmos is still going to be very, very handy. So before we can do any of this, we're going to also pull out that vertex. So we're going to go ahead and we're going to pull out, we pulled out that vertex, insiders lie, -2, -8. That's the beauty of vertex form. Okay, and then we can do our box and we can expand like we've been doing. So we're going to say x plus 2 times x plus 2. What do we get when we do that? X times x is x squared, 2x and 2x and 4. So remember, now I don't have an A. I don't have a number outside of my parentheses. So really, I just have x squared. What do I get right here when I put these together? Plus 4x plus 4. And don't forget that minus 8, right? We got to bring that down. We're going to put those together. We get x squared plus 4x. What's 4 minus 8? 4 minus 8 is -4. So remember, this is our A, this is our B, this is our C. We did that in the last unit. And I want you to remember your y-intercept is your C. So now I know 0, -4. So we could go ahead and we can create our part of our graph even without putting it in the computer. So far we know our y-intercept is 0, -4. That's way down here. And our vertex was -2, -8. Okay, if this is my vertex, I want you to remember that our graph is being split in half right here. Okay, from my axis of symmetry to my y-intercept, it's 2. So where do you think the buddy point is going to be on the other side? How many do I need to go over? I need to go 2 to the left now. This is going to be my buddy point there. What is that? -4, -4. So, and I'll show you also in the computer, but that is how you can find that buddy point, because remember the axis of symmetry is going to split it in half. So when we draw our parabola, it looks like this. So now we've drawn our graph. We filled in all the pieces. We can put this in Desmos to double check everything. So let's have a look at that. All right, let's try another one. Vertex, remember, is your HK. HK. So what is my vertex? Remember, insiders lie to what? To -4. We cannot do the y-intercept yet. That's our C. So we're going to have to change to standard form, ax squared plus bx plus c, in order to get the C and the buddy point, okay? But we do know that over here on our graph, 2, -4, I know that this is my vertex, okay? Is this going to open up or down? Look at the sign of A. It's a positive. Is it going to open up? Is it going to open down? It is going to open up, okay? So we can double check that when we get there. Next step we said was expand. So here's your box. Most of you preferred that. If you like distributing, that's fine too. X minus 2. Be very careful with our signs. X minus 2. Remember, we're not going to do anything with this 1/2 just yet. We're not going to do anything with this -4 just yet. But they do, we're just not using them right now. They don't go poof into thin air. Okay, we still have to have them there. X squared minus 2x minus 2x. What's -2 and -2? Positive 4. Make sure you pay attention to that. What is negative 2x and negative 2x? Negative 4x. Very nice. Signs are going to be a big deal. So now we do have a number outside. We have an a. So we're going to distribute. So we have half x squared. What's half of negative 4? Negative 2. Don't forget the x. And half of a positive 4 is a positive 2. And I got to bring this 4 down. Last step we said, collect like terms. So my standard form is 1/2 x squared minus 2x. What's 2 minus 4? Negative 2. So, oh, look, there's my c. What does that represent? Y-intercept. So 0, negative 2. So now that we know the y-intercept, we also have the vertex. We could find this buddy point, just like we talked about a minute ago. So we're at 0, negative 2. So remember, we've got our axis of symmetry. Remember, that is an x equals. If I asked you the equation, x equals, we go through 2, right? It matches the h. X equals 2. How far away is this from my axis of symmetry? 2 to the left. So I need to go 2 to the right. So what is that buddy point going to be? 4, negative 2. And you should notice that on that buddy point, those y's are going to match. We said earlier it's going to open up. There you go. Again, you can graph it in Desmos to double check all of those things. That's a good way to check yourself as far as did you convert it correctly. So when we put it in Desmos, we graphed our vertex form, we graphed our standard form, we made our table. So we can see our vertex, we can see our y-intercept. I did add, and we did a little bit of this yesterday, we added negative 4 to our table so you can see that buddy point. So that's how you can check yourself.